Welcome to our session on detecting and reporting artificial intelligence incidents. This is part 34 of our AI audit exam prep series. In this session, we will explore why AI systems are mathematically destined to make errors and how we can differentiate a normal mistake from a targeted cyber attack. Understanding this is essential for your career in risk or auditing. When a business unit wants to deploy a new automated tool, you will know exactly how to establish performance baselines and build monitoring systems that prevent catastrophic data corruption without halting daily operations. Let us begin with the fundamental nature of these systems. Unlike traditional software that follows rigid rules, machine learning operates entirely on mathematical probability. This means the system is designed to guess the most likely outcome, and therefore it will make mistakes a certain percentage of the time. Engineers actually avoid trying to make the system 100% perfect on its training information. If they force absolute perfection, they create a problem called overfitting. Overfitting happens when a system essentially memorizes the exact data it was shown, but completely loses the ability to understand any new, unfamiliar information. Imagine teaching someone to drive by making them memorize every single pothole and turn on a specific 1-mile stretch of road. They will drive that specific road perfectly. However, if you drop them in a new city, they will crash immediately because they learned a route, not the actual rules of driving. Because these systems are meant to generalize, defining exactly when a bad prediction becomes an actual security incident is a major challenge for any organization. Because we know the outputs will never be flawless, we must rely on a practice called artificial intelligence observability. Observability simply means constantly monitoring the internal health and real-time outputs of the system. To do this effectively, a company must define clear performance metrics and establish a baseline of what normal behavior looks like. You cannot spot abnormal activity if you have not defined what normal is. Detecting incidents requires a combination of methods. While automated software can track data flows and flag unusual spikes, you also need what is called a human in the loop. This means an actual person must review the flagged anomalies and make subjective judgments that computers cannot make. Think of it like a home security system. The motion sensors might automatically trigger an alarm, but you still need a human to look at the camera and decide if it is a burglar or just the family dog running through the living room. Moving on to specific threats, we must recognize that attacks targeting the underlying data of a model are much harder to spot than traditional data breaches. Security teams are used to looking for data loss, such as hackers stealing customer files or leaking private emails. However, modern threats involve the injection of malicious data. Attackers subtly alter the information, either directly or indirectly, at various stages as it flows through the data pipeline. Instead of stealing your assets, they corrupt them. If traditional data theft is like a criminal stealing the cash from a cash register, malicious data injection is like a criminal sneaking into a currency mint and slightly changing the printing plates. You still have money, but all future bills you produce will be counterfeit and useless. Let us break down 3 common methods attackers use and how you can detect them. The first is prompt injection. This is when an attacker uses tricky language or commands to manipulate a language model into ignoring its safety rules. To catch this, organizations must have processes that evaluate and sanitize all text before it enters the model. You must monitor for atypical input patterns. Red flags include text that looks like computer code, an unnatural amount of special characters, or thousands of very similar requests with only tiny variations in the wording. The second threat is data poisoning. This occurs when an attacker corrupts the massive datasets used to train the system. To spot this, auditors must continuously monitor the access and change logs across the entire data supply chain. You must review the data preparation scripts to ensure no one made unauthorized edits. Furthermore, you should verify the dataset version histories and cryptographic hashes. A hash is a unique digital fingerprint for a file. If the fingerprint changes, you know the data was tampered with. Finally, we have adversarial inference. This involves an attacker repeatedly poking the system with strategic questions to figure out its underlying rules or steal its private training data. The primary detection method here is analyzing the logs of your application programming interfaces, which are the digital bridges that allow software to communicate. By scanning these connection logs, You can spot anomalous patterns that reveal someone is systematically probing your defenses. To summarize our session, remember that artificial intelligence is probabilistic and not designed for absolute perfection. Because mistakes are expected, you must build robust observability metrics and use a human in the loop to identify true incidents. Finally, be vigilant against complex threats like prompt injection, data poisoning, and adversarial inference by monitoring inputs, auditing supply chain logs, and analyzing system connections. All the important topics and concepts from this session are covered in the multiple choice questions on RooCloud.com. I highly recommend you log in and solve the chapter-wise questions to reinforce your learning before we move on to the next session. Thank you for watching, and I will see you in the next episode.